Okay, so this is an electron at a point in an electric field. You can tell by the field lines that this is positive and this is negative. So drawing an arrow to show the direction of the force that acts on the electron. So the electron is going to be attracted to the positive end. The force is that way. State and explain what, if anything, will happen to the magnitude of the electrostatic force acting on the electron as it starts to move. Well, the field is the same for all points. It is a uniform field. So as the electron starts to move, the force is unchanged. E equals F over Q. The charge of the electron is Q. The field is uniform. F equals EQ. These are constant, so the force is constant. So F is constant because E is constant. So the next part of the question is on two charges in non-uniform electric fields. I'll put the positive and the negatives on. And I can see that the field strength is getting stronger at this side, weaker over here, because the field lines are further apart over there. Same on the other side, one's a proton, one's an electron. So state and explain how the electrostatic force on the proton in 2b compares with that on the electron in 2a. F equals EQ. Both the same field. Electron has the same charge as a proton in magnitude. So F is equal in magnitude. But it's in the opposite direction. This one this way, this one this way. So the next part of the question, each of the particles starts to move from the position shown in figure 2a and b. State and explain how the magnitude of the initial acceleration of the proton compares with that of the electron. Okay, as you can see, the proton is going to be accelerated in this direction. The electron is going to move off in this direction. The field gets stronger over here, the field gets weaker over here. The only other thing to think about is the mass of both of them. And the mass of the proton is 2,000 times greater than that of the electron. So the acceleration of the proton at the beginning will be a lot less than the acceleration of the electron, purely due to its mass. So acceleration of proton is greater smaller than electron. P is heavier, or it has a greater mass. Okay, the last part is describe and explain what will happen to the acceleration of each of these particles as they continue to move in the electric field. if you go back to the previous diagram, if you remember, the field lines went like this, and this was electron. And they were like this for the proton. The electron is going to travel this way. The proton travels to the right, so the proton is moving into an area where the electric field is stronger. If the electric field strength is greater, then the force will start to be of a greater magnitude. Therefore, the acceleration will start to increase for the proton. The acceleration for the electron, well, that's moving into an electric field strength area which is weakening. Therefore, we know E equals F over Q. If E weakens, F weakens, and if F weakens, the acceleration decreases. So proton increases acceleration, electron decreases. So the last part, a line spectrum of neon gas contains a prominent red line of wavelength 650 nanometers. Show that the energy required to excite neon atoms so they emit light of this wavelength is about 2 electron volts. So we remember from quantum, E equals hc over lambda, which equals 6.63 times 10 to the minus 34 times 3 times 10 to the 8 all over 650 times 10 to the minus 9. That will equal 3.1 times 10 to the minus 19 joules. To convert that into electron volts, you'll divide by 1.6 times 10 to the minus 19. Which equals 1.9 electron volts, which is approximately 2 electron volts. Okay, so the last part of question C. Illuminate shop sign has a neon discharge tube. PD 4500 volts applied across the electrodes. 180 millimeters apart. Electric field inside the tube is uniform. Calculate the minimum distance that a free electron would have to move from rest in order to excite the red spectral line. So it will gain some energy. This electron starts moving, it gains some energy. So we know the electric field strength equals V over D, which equals 4500 over 180 times 10 to the minus 3. Put it over this side, 2.5 times 10 to the 4 it's volts per meter. We know that the work done on the electron, 3.1 times 10 to the minus 19 joules. And work done equals force times distance. This is the distance that we're after. So E equals F over Q. So F equals EQ. E was this figure here. So 2.5 times 10 to the 4 times the charge of an electron, 1.6 times 10 to the minus 19. It's 4 times 10 to the minus 15, so that's the force on the electron, which is this force here. So we know that the work done is 3.1 times 10 to the minus 19. We know the force is 4 times 10 to the 15. We'll write that on there. 4 times 10 to the minus 15. So it's 1 divided by the other. So 3.1 times 10 to the minus 19 divided by 4 times 10 to the minus 15. 7.8 times 10 to the minus 5 meters.